Good day, learners! Welcome to another fun and exciting lesson in Mathematics 10. I am Teacher Angelo and I will be your guide in learning the lesson for the day. But before we start, make sure that you are in your most comfortable seat and have your learning module, your pen and paper ready with you. Do you have it? Let's start! At the end of the session, you are expected to illustrate the following measures of position: quartiles, deciles, and percentiles. Calculate a specified measure of position, like the 90th percentile of a set of data. Interpret measures of position and solve problems involving measures of position. Before we discuss the different measures of position, it will be helpful to review the different measures of central tendency, which were discussed in your Math 7 and Math 8 lessons. To do this, we'll have a short activity entitled Scrambled Letters. Are you ready? Let's do this! In this activity, you are going to unscramble the scrambled letters to form a word that represents the given definition. Let's start with item number 1. It is found by adding all the numbers in the data set and then dividing by the number of values in the set. The word is correct. It is mean. What about this next item? It is the middle value when a data set is ordered from least to greatest. The word is that's right. It is median. Now try this last item. It is the number that occurs most often in a data set. The word is very good. It is mode. Now that we have already reviewed the different measures of central tendency, it is time to learn a new lesson on the measures of position. Do you know the most popular Chinese zodiac legend? Let us watch a video entitled The Great Race, which is the story of how the Chinese zodiac was created. Take note of the different positions that the animals get in the story.
Long ago, the Jade Emperor, ruler of the heavens, devised a new way to count the years. He created a calendar based on a 12-year cycle that would grant humanity the power to measure time. In celebration, he summoned the animals of the world to a great race. They were tasked with crossing a wide river, and as a reward, the years of the calendar would be named after them, in the order in which they arrived. Among those who answered the call were the dragon, the tiger, the snake, the horse, the ox, the dog, the monkey, the rabbit, the goat, the rooster, the pig, the cat, and the mouse. The race began at dawn. In those days, the cat and the mouse were the best of friends, and they were both poor swimmers. They convinced the patient ox to allow them to ride on his back. "Take us with you," they said, "and we will show you the way." When they neared the opposite shore, the mouse pushed the cat into the water. Then, at the last moment, the rat leapt off the ox's head and landed on the wet dirt. This is how the cunning mouse became the first animal of the lunar calendar. Though disappointed, the dependable ox was able to capture the second position. In third place came the tiger, who, while fast on land, had trouble fighting the river currents. Soon after came the rabbit, who had nearly drowned. To cross the river, he had hopped from stone to stone, but slipped at the final moment. He was able to hold on to a fallen tree branch, until a gust of wind pushed him onto the shore. Soon after, a large shadow was cast over the riverbank. It was the fearless dragon, there to claim the fifth position. This surprised the Emperor. How does one as swift and as brave as you arrive in fifth place? On my approach, I discovered villagers suffering a terrible drought, and so I stopped to make rain for them. Then, I discovered a little rabbit clinging to a tree branch and sent a gust of wind to push him to the shore. At this, the Emperor was greatly pleased and welcomed the dragon to his rightful spot. Soon after came the sound of hooves, signaling the arrival of the horse. However, the clever snake had hidden himself in the horse's mane and jumped to the ground once safely across. This startled the horse, allowing the snake to capture the sixth position. The horse finished seventh. The next three positions were awarded to the goat, the monkey, and the rooster. At the start of the race, the observant rooster had noticed an abandoned raft behind tall blades of grass. However, knowing that he would not be able to cross the river on his own, he invited the monkey and the goat to help. Moved by the goat's kind nature, the other animals allowed her to finish eighth, followed by the happy monkey and the hard-working rooster. In 11th place came the playful dog. Although an excellent swimmer, he spent much of the race frolicking in the water. Finally, in 12th place was the honest pig. He had gotten hungry and stopped to eat, and then taken a long nap. When he awoke, he floated across the river on his belly. "Congratulations, pig," said the Emperor. "I have saved for you the final spot on my calendar." And with that, the years of the Chinese zodiac were decided. When people are born, they are said to inherit the personality traits and compatibilities of their own animal sign. As for the cat, he finally made it across the river, but not in time to secure a place on the calendar. That is why, to this day, cats and mice are mortal enemies.
Do you like the story? Great! Now let's recap the positions the animals get in the Great Race. Will you help me arrange them in order? That's good! According to the legend, the Jade Emperor made an order to designate animals as the calendar signs. These are the 12 animals that arrived first in the banquet. The one who got up early and rushed to the banquet was... Yes, that's the rat. Followed by the ox. The third animal in the banquet was the tiger. Then they were followed by the rabbit. The fifth animal who came was... Yes, it's the dragon. Who's next? Yes, it's the snake. The seventh animal was the horse. Then it was followed by the goat. Next is the monkey. Then the rooster came. The 11th animal was the dog. Last but not the least is the pig. Now let's answer the following questions. Number 1. Which of the following belongs to the first 50% that arrived earlier than the rest of the group? A. The tiger, B. The rabbit, C. The dragon, or D. All of them? The correct answer is... You're right! It's letter D. All of them. Let us have the second item. Which of the following belongs to the second 50% that arrived later than the rest of the group? A. The horse, B. The snake, C. The dragon, or D. None of them? The correct answer is... You're right! It's letter A, the horse. Now let's have question number 3. Which of the following represents the median? A. The dragon, B. The snake, C. The horse, or letter D. None? What do you think is the answer? That's correct! It's letter B, the snake. Now let's try this fourth item. Which of the following belongs to the first 25% that arrived earlier than the rest of the group? A. The tiger, B. The rabbit, C. The dragon, or D. The snake? What do you think is the answer? You're right! The answer is letter A, the tiger. Tiger belongs to the first 25% that arrived earlier than the rest of the group. Now let us have the last item. How many percent of the animals arrived later than the tiger? A. 25%, B. 50%, C. 75%, or D. 100%? What do you think is the answer? That's it! It's letter C, 75%. Those animals belonging to 75% are the rabbit, dragon, snake, horse, goat, monkey, rooster, dog, and the pig. What we have just answered relate to our lesson for the day, which is about the measure of position. Measure of position is a measure by which the position of a data is determined through its value. Will you read it again? Very good! From the previous activity, we observed that each animal has a position. Take for example, the tiger. The tiger belongs to the first 50% or top 50% of the group that arrived earlier than the rest of the animals. The tiger belongs to the first 25% or top 25% of the group that arrived earlier than the rest of the animals. Also, the tiger arrived earlier than the 75% of the animals. Interestingly, based on this example, we can say that there are several measures that can be used to describe the position of the tiger. One measure that you had discussed when you were in grade 7 and grade 8 was the median. In applying the concept of a median, you arrange all the observations, scores, or data in either ascending or descending order. This ordered set is then divided into two equal parts. The median then is the middle number that divides the data into two equal parts. 50% of the data is below the median, or what we call the lower half. In the story, the median is the snake, because 50% of the animals arrived later than the snake. The animals that belong to the first 50% of the group that arrived earlier are the rat, ox, tiger, rabbit, dragon, and snake. The animals that belong to the 50% of the group that arrived later are the horse, goat, monkey, rooster, dog, and the pig. Now, let us have a recap on the concept of a median. Let us first consider a data set with odd number of values. Example number 1. In their physical education class, 7 students practiced shooting the basketball from the free throw line for 20 times. Below is the list of the unsuccessful shots done by the 7 students. 9, 3, 5, 6, 8, 10, 11. Find the median of the data set. To find the median, first, let us arrange the values in ascending order. So the values will be written as 3, 5, 6, 8, 9, 10, 11. Then, find the middle number. Since there are 7 values, the middle is the fourth value counting either from left or right. And that is 8. Therefore, the median is 8. This means that about 50% of the group has a lower number of successful shots than 8, and about 50% of the group has a higher number of successful shots than 8. Let us proceed in finding the median of a data set with even number of values, with example number 2. In their physical education class, 8 students participated in throwing the shot put. Below is the list of how far the shot put reached per student. 17, 7, 5, 9, 11, 3, 13, 15. Find the median of the data set. To find the median, first, let us arrange the values in ascending order. So the values will be written as 3, 5, 7, 9, 11, 13, 15, and 17. Then, find the middle number. Since there are 8 values, then the middle values are the fourth value from the left and the fourth value from the right. So we have 9 and 11. Notice that there are 2 values. Now to get the median, we will find the mean of these 2 values. The median is the mean of the 2 values 9 and 11. To find the median, we add 9 and 11 and then divide the answer by 2. 9 plus 11 is equal to 20. Divided by 2, the answer is 10. Therefore, the median is 10 meters. This means that 50% of the group threw shorter than 10 meters, and 50% of the group threw longer than 10 meters. Let us say Hero is one of the students who threw the shot put and his throw reached 15 meters. This means that Hero belongs to the group that threw the shot put farther than 10 meters. This time, you are going to apply the concept of a median with this activity. Here is a table containing the list of fruits high in sugar. What you're going to do is to find the median fruit, then describe the position of peers. If you have the answer to this activity, just comment or kindly give your answer to your teacher through the FB Messenger. Were you able to find the median and the fruit that represents the median in the previous activity? Very good! In the previous activity, we only divided the dataset into two equal parts. But we may divide the dataset into more parts of equal sizes, such as into 4, 10, or even 100 parts. Doing this will require us to compute for the quartiles, deciles, and percentiles respectively. Now let us discuss the first measure of position, the quartiles. Quartiles are values which divide a list of ordered numbers into 4 equal parts. There are 3 quartiles which are denoted as Q sub 1, Q sub 2, and Q sub 3. Will you read it again? Very good! Q sub 1 is what we call the first quartile, which is found on this part. Q sub 2 is what we call the second quartile, which is found at the middle part. And Q sub 3 is what we call the third quartile, which is found in this part. If the data are arranged in ascending order, the second quartile is the median of the data set. This means that 50% of the numbers in the data set lie below the second quartile. The first quartile, or the lower quartile, is the median of the lower half of the data set. This means that 25% of the numbers in the dataset lie below the first quartile. The third quartile, or the upper quartile, is the median of the upper half of the dataset. This means that 75% of the numbers in the dataset lie below the third quartile. Going back to the story, for the first quartile, we can claim that the rat, the ox, and the tiger belong to the 25% of the group that arrived earlier in the banquet. The rat, ox, tiger, rabbit, dragon, snake, horse, goat, and monkey belong to the 75% of the group that arrived earlier than the rest of the group. Now activity time! Here is an activity for you to discover how to find the quartiles. Follow the steps to find the different quartile values. 11 students recorded the number of laps of swimming they were able to do in a 25-meter pool. Below is the number of laps they did. 6, 8, 5, 4, 3, 2, 2, 6, 1, 9, and 7. Now, to find the different quartile values, first, with your pen and paper, arrange the values in ascending order. Are you done? Let us proceed with the second step. Identify the median. This is the second quartile. Do you have the value now? Good. Let's proceed with the third step. Identify the lower half of the values. Just encircle the lower half. Step number 4. Identify the median of the lower half of the values. This is the first quartile. Do you have the value now? Great! Let's proceed with the fifth step. Identify the upper half of the values. You may encircle the upper half of the values. Now let us have the sixth step. Identify the median of the upper half of the values. This is the third quartile. Do you have the value now? Now let's check your answers. Now let us have the first step. The values should be arranged in this order: 1, 2, 2, 3, 4, 5, 6, 6, 7, 8, and 9. Now let us have the second step. Identifying the median. The median is the middle number, which is 5. Therefore, 5 is also our second quartile. Third step is to identify the lower half of the values. The lower half are the values found below the median, which are 1, 2, 2, 3, and 4. Fourth step, identify the median of the lower half. The median of the lower half is the middle value, which is 2. Now this is the value of our first quartile. Fifth step is to identify the upper half of the values. The upper half of the values are those values found on the right side of the median, which are 6, 6, 7, 8, and 9. And the last step, identify the median of the upper half of the values. The median of the upper half is the middle number, which is 7. 7 is our quartile number 3, or the third quartile. Were you able to accurately determine the different quartiles of the previous activity? That's good! Since the second quartile is equal to the median, the steps in finding the median of the dataset is the same. To find the first quartile, we get the median of the lower half. To find the third quartile, we get the median of the upper half. This process is known as the Tukey's method. Let us try some examples. Example number 1. Averina, a shoe store owner, wanted to compare the different brands of shoes. The table shows her record of the number of pairs of shoes bought from each of the brands in 1 week. Find the first quartile, the second quartile, and the third quartile. First, arrange the numbers of pairs of shoes in ascending order. So we have 5, 8, 9, 10, 11, 14, 15, 17, 18, 19, and 21. Next is to find the median of the number of pairs of shoes. This is the second quartile. The median of the ordered set of values is 14. And that is our second quartile. Second quartile is equal to 14. Now we already have the second quartile. Next is to find the first quartile. To find the first quartile, identify the lower half of the number of pairs of shoes. We have 5, 8, 9, 10, and 11. Next is identify the median of the lower half of the number of pairs of shoes. This is the first quartile. The median of the lower half is... That's correct, it's 9. 9 is our first quartile. So we have first quartile is equal to 9. This time, we will find the value of the third quartile. In order to find the value of the third quartile, identify the upper half of the number of pairs of shoes. We have 15, 17, 18, 19, and 21. Then, identify the median of the upper half of the number of pairs of shoes. This is our third quartile. The median of the upper half is... That's correct, it's 18. So 18 is our third quartile. Now let us try another example. Alice wanted to compare the fruits with high water to substitute water to hydrate the body and found the following data. Find the first quartile, second quartile, and third quartile. First, arrange the amounts of water per cup in ascending order. So we have 107, 128, 137, 138, 141, 142, 151, 209. Next is to identify the median of the amounts of water per cup. This value will be referring to our second quartile. Now, the median of this ordered set are the values 138 and 141. Remember, if you have two values as the median, we are going to find the mean of these two values. By doing this, we will add 138 and 141. Then we will divide the answer by 2. So we have 138 plus 141 is equal to 279. Divided by 2, the answer is 139.5. Therefore, our second quartile is 139.5. Now let us find the value of the first quartile. In order to find the value of the first quartile, identify the lower half of the amounts of water per cup. So we have 107, 128, 137, and 138. Next is to identify the median of the lower half of the amounts of water per cup. This is the first quartile. So we have the median, 128 and 137. As you notice, we have two values. The same with what we have done a while ago. To find the median of these two values, we will find the mean of 128 and 137. By doing this, we will add the values and divide the answer by 2. So we have 128 plus 137 is equal to 265. Divided by 2, the answer is 132.5. Therefore, our first quartile is 132.5. Lastly, we will find the third quartile. To find the value of the third quartile, identify the upper half of the amounts of water per cup. So we have 141, 142, 151, and 209. Then, identify the median of the upper half of the amounts of water per cup. This value is our third quartile. So the median of the upper half are 142 and 151. Again, as you notice, there are two values. So what are we going to do? That's correct. We will find the mean of 142 and 151. By doing this, we will add 142 and 151, then divide the answer by 2. So we have 142 plus 151 is equal to 293. Divided by 2, the answer is 146.5. And this is our third quartile. Do you know that there is another method of finding quartiles? Let's check this out. Another method of finding quartiles is the Mendenhall-Essensic method. Given a data set with n number of values, first, we arrange the data in ascending order. Next, we find the position of the first quartile in the data set using the formula. Position of the first quartile is equal to 1/4 times quantity n plus 1 closed quantity. As you notice, the numerator of the fraction is 1, which is the same with what quartile we are looking for, the first quartile. Then round off to the nearest integer. Finally, look for the value of the first quartile in the data set using the computed position. To find the position of the third quartile in the data set, use the formula. Position of the third quartile is equal to 3/4 times quantity n plus 1 closed quantity. Again, take note that the numerator of the fraction is 3, which is the same with what quartile we are looking for, the third quartile. Then round off to the nearest integer. Finally, look for the value of the third quartile in the data set using the computed position. Now, let us apply the Mendenhall-Essensic method in solving this example. Alucard, a coffee shop owner, recorded the number of orders of the different coffee drinks in a day. Find the first quartile and the third quartile using the Mendenhall-Essensic method. First, we will be looking for the value of the first quartile. So what we are going to do is to arrange the values in ascending order. So we have 2, 3, 5, 5, 6, 7, 8, 9, and 10. Next, locate the position of the first quartile using the formula and round off to the nearest integer. Since there are 9 values in the dataset, therefore n is equal to 9. Using the formula, position of the first quartile is equal to 1/4 times quantity n plus 1 close quantity. Substitute 9 to n. So we have 1/4 times quantity 9 plus 1 close quantity. 9 plus 1 is equal to 10. So we have 1/4 times 10 is equal to 2.5. 2.5 is approximately equal to 3. Therefore, our first quartile is the third value in the ordered set of values. Find the value of the first quartile in a data set using this computed position. Going back to the ordered set, we have the third value, which is 5. Therefore, the first quartile is equal to 5. Since we have the value of the first quartile, this time we will be looking for the value of the third quartile. In order to do this, locate the position of the third quartile using the formula and round off to the nearest integer. Again, since there are 9 values in the dataset, n is equal to 9. Using the formula, position of the third quartile is equal to 3/4 times quantity n plus 1 close quantity. Substitute 9 to the value of n. So we have 3/4 times quantity 9 plus 1 close quantity. 9 plus 1 is equal to 10. So we have 3/4 times 10 is equal to 7.5. 7.5 is approximately equal to 8. Now find the value of the third quartile in the dataset using the computed position. The third quartile is the 8th value. Going back to our ordered set of values, our 8th value is 9. Therefore, our third quartile is equal to 9.
This time, let us discuss another measure of position, the deciles.
The median divides the dataset into 2 equal parts. Quartiles divide the dataset into 4 equal parts. Deciles, on the other hand, are values that divide the dataset into 10 equal parts. There are 9 deciles, which are denoted as D sub 1, D sub 2, D sub 3, D sub 4, D sub 5, D sub 6, D sub 7, D sub 8, and D sub 9. If the data are arranged in ascending order, D sub 1, or the first decile, would mean that 10% of the data lie below it. D sub 2, or the second decile, would mean that 20% of the data lie below it. Deciles are computed in the same way as the quartiles. First, we arrange the data in ascending order. Then, locate the position of the deciles in the dataset using the formula. Position of D sub k is equal to k over 10 times quantity n plus 1 close quantity. The value of k here, which is the numerator, is equal to the value of the decile that we are looking for. For example, we are looking for the 8th decile, therefore the value of k is 8. The fraction becomes 8 over 10. Then round off to the nearest integer. Then find the value that corresponds to the computed position. Now let's apply this in answering the next example. Mr. Ling is an English teacher. He is interested in the reading speed of his students. The following are the numbers of words his students can read in 1 minute. Find the 7th decile. To find the 7th decile, first, arrange the numbers of words read by the students in 1 minute in ascending order. So we have 10, 11, 11, 11, 12, 13, 16, 16, 19, 20, 23, 25, 30, 42, and 50. Then, locate the position of the 7th decile using the formula and round off to the nearest integer. Since there are 15 values in the dataset, then n is equal to 15. And we are looking for the 7th decile, then k is equal to 7. With the use of the formula, the position of the 7th decile is equal to k over 10 times quantity n plus 1 closed quantity. Substitute the values of k and n. So we have k is equal to 7 over 10 times quantity n is 15 plus 1 closed quantity. 15 plus 1 is equal to 16. So we have 7 over 10 times 16. Multiply the numerators, 7 and 16, the result is 112. Divided by 10, the answer is 11.2. 11.2 is approximately equal to 11. Now going back to our ordered set of values, the 7th decile is the 11th value in the data set, and that is 23. Therefore, the 7th decile is equal to 23. You already know how to compute a decile value. Now let's try another one. This time, let's focus on interpreting a given decile with this next example. In Mr. Ling's class, Liza finished her exam in just 30 minutes. The time Liza spent in answering the test is the 8th decile. What does this mean? Now, let's use a diagram to interpret the given problem. As the problem says, Liza is on this part, the 8th decile. This means that 80% of her classmates finished the same test by spending the same amount of time or longer time than her. Or 80% of her classmates answered the test same time as hers or were slower than her.
We already have learned the first two measures of position, the quartiles and the deciles. This time, let's learn the third one, the percentiles.
The median divides the dataset into two equal parts. Quartiles divide the dataset into 4 equal parts. Deciles divide the dataset into 10 equal parts. Percentiles, on the other hand, divide the dataset into 100 equal parts. There are 99 percentiles, which are denoted as P sub 1, P sub 2, P sub 3, until P sub 99. With the use of the diagram,
This is P sub 10. This is P sub 20, P sub 30, P sub 40, P sub 50, P sub 60, P sub 70, P sub 80, and P sub 90. If the data are arranged in ascending order, P sub 1, or the first percentile, would mean that 1% of the data lie below it. Percentiles are computed in the same way as the quartiles and the deciles. First, we arrange the data set in ascending order. Then, locate the position of the percentiles in the data set using the formula position of P sub k is equal to k over 100 times quantity n plus 1 close quantity. Again, the value of k here, which is the numerator of 100, is equal to the value of the percentile that we are looking for. Example, if we are looking for the 10th percentile, the value of k is equal to 10. Thus, the fraction becomes 10 over 100. Then round off to the nearest integer. Then find the value that corresponds to the computed position. Now let's apply this in answering the next example. The given table shows the list of the most endangered animals on Earth. Find the 70th percentile of the numbers of endangered animals. To find the 70th percentile, first, we arrange the values from the least endangered to the most endangered animal using their given numbers. So we have 2,500, 1,000, 800, 562, 380, 350, 340, 300, 300, 140, 84, 70, 68, 50, and 10. Then, locate the position of the 70th percentile using the formula and round off to the nearest integer. Since there are 15 values in the dataset, then n is equal to 15. And we are looking for the 70th percentile, then k is equal to 70. Using the formula, position of the 70th percentile is equal to k over 100 times quantity n plus 1 close quantity. Substitute the values of k and n. K is equal to 70, so we have 70 over 100 times quantity, n is equal to 15, so we have 15 plus 1 close quantity. 15 plus 1 is equal to 16. So we have 70 over 100 times 16. Multiply the numerators, so we have 70 times 16 is equal to 1,120. Divided by 100, the answer is 11.2. 11.2 is approximately equal to 11. Therefore, the 70th percentile is the 11th value in the data set. Going back to the ordered set of values, our 11th value is 84. Therefore, the 70th percentile is equal to 84. Going back to the table, the value of the 70th percentile, which is 84, means that the Amur leopard is more critically endangered compared to 70% of the group of endangered animals.
Have you learned something from our discussion on the measures of position? That's great! Now, before we proceed to the assessment, let us do a short recap of the important points in this session.
The measure of position is a measure by which the position of a data is determined through its value. The measures of position discussed in this session are quartiles, deciles, and percentiles. Quartiles divide the ordered set of data into 4 equal parts. Deciles divide the ordered set of data into 10 equal parts. And percentiles divide the ordered set of data into 100 equal parts. Always remember, in finding the measures of position of a given data set, we always start by arranging the data in either ascending or descending order, depending on the variable under study. There are 2 methods discussed in finding for quartiles, the Dukes method and the Mendenhall and Sensich method. Measures of position are computed in a similar manner.
Now, are you ready to measure your learning? Awesome! Let's take this short quiz.
Quiz time! Read and answer each of the following items accurately. Write the letter of your answer on your answer sheet. For items 1 to 4, refer to the given table on the countries with the highest number of COVID-19 cases as of July 30, 2020. Item number 1. What is the upper quartile or the third quartile of the data? A. 261,457. B. 471,123. C. 620,333. Or D. 1,021,611. Item number 2. What is the fifth decile of the data? A. 261,457. B. 327,690. C. 395,005. Or D. 471,123. Item number 3. What is the 80th percentile of the data? A. 471,123. B. 620,333. C. 1,021,611. Or letter D. 2,555,518. Item number 4. Which country has a higher number of COVID-19 cases compared to the country in the 40th percentile? A. Iran. B. Pakistan. C. United Kingdom. Or letter D. Spain. Last item, item number 5. In the 2019 National Career Achievement Examination or NCAE, Esmeralda score in the Mathematics Ability Test is at 99th percentile rank. What does this mean? A. Esmeralda scored the highest. B. Esmeralda score is 99 points. C. Esmeralda is the 99th in position among all the examinees. Or letter D, Esmeralda scored higher than the other 99% of the examinees. Are you done with your answers? Very good. This time, look at your answers and check if you get the correct answer in each item. Item number 1. What is the upper quartile or third quartile of the data? What is your answer? That's right. The answer is letter C, 620,333. Item number 2. What is the fifth decile of the data? What is your answer? Very good. The answer is letter B, 327,690. Item number 3. What is the 80th percentile of the data? What is your answer? That's good. The answer is letter C. It's 1,021,611. Item number 4. Which country has a higher number of COVID-19 cases compared to the country in the 40th percentile? What is your answer? Great! The answer is letter C, United Kingdom. Now for the last item, in the 2019 National Career Achievement Examination or NCAE, Esmeralda's score in the Mathematics Ability Test is at 99th percentile rank. What does this mean? What is your answer? Awesome! The answer is letter D. Esmeralda scored higher than the other 99% of the examinees.
Great job! Now let's see. What's your score? Congratulations for doing your best.
To practice and extend your learning on the measures of position, here is an additional activity for you to work on. Make an online survey with your classmates. Think of a question that will prompt you and your classmates to give a quantitative data. Find the third quartile, 10th decile, and the 99th percentile. Find your position based on the data values and make an interpretation. If you don't have internet connection to conduct an online survey, you may utilize the members of your family at home. If you are done with your activity, you may submit your output through the email account angelo.gutierrez001@deped.gov.ph, or you may submit your output to your teacher at school.
That concludes our lesson for the day. See you again on the next learning discussion. I am Teacher Angelo, your buddy in learning math. Keep safe and have a good day.